Good morning, students, and welcome to PURNACHANDRA Higher Secondary School. In the previous class, we are discussing about unit. Okay, what is unit? What is a measurement? Then what are the types of unit? That is your fundamental units, derived units. Okay, these things we have discussed in the previous video lecture. So in this class, we are discussing a very important point, a very important theme, that is your dimension and dimensional analysis. Okay. So before that, let us discuss one more very small but very important point, that is system of units, which is left in the previous class. First of all, we have to discuss about system of unit. Okay, system of units. So system of, first of all, what do you mean by system of units? The system of units is the accumulation or the collection of units. Okay, collection of units to represent all the physical quantities using the fundamental units. So that is the system of units. System of units are the, again I will repeat, system of units is the set of collection of all units. Set of collection of all units which is represented, okay, which is used to represent the unit of physical quantities. Clear? So now, what are the types of system of units? Let us discuss. The first one is your CGS. Okay. The second one is your FPS. Third one is your MKS. Fourth one is your SI. Clear? So these are the four types of system of units. The first one is your CGS. CGS, what CGS stands for? Let us discuss somehow. Okay. C. Okay. So C stands for centimeter. C stands for centimeter. Clear? Which is the unit of length. Then G. Okay. G stands for gram, which is the unit of mass. Clear? So these are the unit. These are the physical quantities: length, mass, and the last one, that is just second. Okay. So second, that is the unit of time. Now these things stands for in this manner in the first system of unit. Okay. Then come to the second system of unit, that is an FPS. F stands for foot. Clear? So foot, the physical quantity which is used to measure foot, that is your length. Okay. Then P is your pound. Okay. So pound is the unit of mass. Then S similarly your second, which is unit of time. Clear? Then come to the MKS. MKS is M stands for again meter. Okay, and which is the unit of length. Then K stands for kilogram. Okay, unit of mass. Then S, similarly the S stands for a second. Okay, which is unit of time. So these three actually the most fundamental one: CGS, FPS, and MKS. Okay, then I come to the last one. Let us discuss about the last one. Apart from these three, that in 1960, okay, there is a measuring committee which decide, or they are deciding to use a universally accepted unit for the all physical quantity. Then they called, or they name it as International Standard of Unit. They call it as International standard of unit. Okay, in 1960, the weight measuring committee, okay, they decided to use a universally accepted system of unit which is used to measure all the physical quantities in the universe, and they call it as International Standard of Unit, simply SI. Clear? And in the SI, in the International Standard of Unit or SI system of unit, in the previous session or in the previous video lecture, we are discussing about, look at here, we are discussing about 7 fundamental or basic units. So the SI, the International Standard of Unit, what it consists of? It consists of 7 fundamental or basic units and 2 supplementary units. 2 supplementary units, which we have already discussed in our previous session or in our previous class. Okay, there are 7 basic fundamental units and 2 supplementary units. 7 fundamental units and also 2 supplementary units. About these we have already discussed in our previous session. Clear? So these are the system of units. We have to know about something. Okay, so now let us enter into our original discussion, that is dimension. Okay. So first of all, let us discuss about dimension. First of all, we know what do you mean by dimension. Okay. So dimension is nothing but, remember, dimension is nothing but the powers or exponents. Okay, of what? Now, of fundamental or basic units which used to express, okay, the physical quantities, the dimension of physical quantities. That is very important. Again, I will repeat. The dimension is nothing but the exponent or power of basic or fundamental physical quantities which are used to represent the other physical quantities. That power or that exponent is called dimension of that physical quantities. Clear? So let us discuss how the dimension can be represented. Look at here. Suppose let us take any physical quantity. Let us take a physical quantity of force. This is a very fundamental physical quantity. Force denoted as F. Clear? So what do you have to find out? Now we have to find out the dimension of force. Very simple. Okay. So force. So what is the general formula of force? I think all of you know is a very fundamental formula. Force is nothing but that is mass into acceleration. Okay. This is the most fundamental formula. That is force is equal to mass into acceleration. Suppose for the mass I am taking m. Okay, and for acceleration I am taking a. So that means the force is equal to ma. This is the formula. Now with the help of this formula, what I have to find out? Now I have to find out the dimension of this one. Now how? Now according to our definition, what is our definition? Just I told before. Now the definition is that it is the power or exponent of fundamental or basic physical quantity. So let us find out. The force is equal to mass into acceleration. We know that mass is a fundamental quantity, but acceleration is not a basic or fundamental physical quantity. It is a derived quantity. So that's why we first represent acceleration. Okay, we first represent the acceleration in terms of the fundamental or basic quantity. So let us convert. So that is equal to, so this is mass m into acceleration formula, all of you know, that is your velocity v divided by time t. Again, let us look at it. Mass is a fundamental one, time is a fundamental one, but velocity is not a fundamental one. Velocity again is a derived one. So again we will convert the velocity to the fundamental using the fundamental quantity. So let us find out. Okay, so this is mass m into velocity. So what is velocity? Now velocity is your length length. Okay, so length divided by time, very simple. Or you can tell that displacement divided by time. But as we are not familiar with the word displacement, so we are discussing or we are mentioning here length, simply length, because the displacement is measured in terms of length. Okay, so length divided by time, whole divided by again time. Now look at this expression. So mass is a fundamental one or basic one. Length is also a basic one. Time is also a fundamental physical quantity. Time is also a fundamental physical quantity. Now we have converted to this one. Now next step we are just find out what is the dimension of this one. Okay, so that is equal to, here I have to mention one thing. Okay, for mass, the dimensional formula we have to take capital M. For length we have to take capital L. For time we have to take capital T to write the dimension. Okay, so for mass I have to take capital M. Okay, for length, look at here, for length I have to take capital L. So this is your capital L. Okay, then divided by time to take capital T, and whole divided by I have to take again capital T. Okay, so now this is equal to, just I have to solve this. So this is M, this is L. Okay, so M means what is the power of M? Very simple. The power of M become M to the power 1. What is the power of L here? Again it is nothing, that means L to the power 1. Very simple. Now this T, okay, this T will come to this denominator. This is numerator, this denominator. Okay, so let us come to this one. So when I come to this one, then in below I have to write this is a T to the power 2. That is simple. Okay, so now come to here. Let us solve it here. So what I can write? Now F, finally, F is equal to, so that is M to the power 1. That is L to the power 1. And when T to the power 2 is in denominator, when it will come to the numerator, this should be T to the power minus 2. That is simple. And we have to put a square bracket in this manner. Now look at this expression. Suppose I will take it as equation number 1. Okay, so now this equation number 1, look at this equation number 1. This is the dimension of which physical quantity? Now force. So what are the dimensions? According to our definition of dimension, what the definition says? Now the definition says these are the exponents or the powers of basic or fundamental physical quantities. So let us see. So what is the power of M? 1. What is the power of L? The 1. What is the power of T? No, minus 2. Very simple. So that's why these are nothing but the dimensions of the physical quantity force. Clear? And the equation number 1, remember the equation number 1 is called dimensional formula. This is called dimensions. Again I will repeat, these are 1, 1, minus 2. These powers are called dimensions, and the equation number 1 is called dimensional formula of this physical quantity, direct physical quantity, that is your force. Simple. Okay, so this is some of the, or how to find out the dimensional formula, and there are so many dimensional formula I have given in my note, okay, which is provided to you. So just kindly students go to my notes, and there are so many dimensional formula of different physical quantities. Okay, so you have to practice that dimensional formulas. Okay, such as I have to mention some of these. So force, I want to mention among some of these. What are the some of these? That is your, first of all, that is your velocity. Some of these I have to mention. That is your velocity v. So v is nothing but that is your length divided by time. That's why I have to retain here L to the power 1, T to the power minus 1. This is the formula. Then come to, these are the fundamental ones. Then come to your acceleration. Okay, acceleration, suppose I will take it as A. So A is nothing but again V by T. Simple, V by T. So V already I know here. So that is L1 T to the power minus 1. L1 T to the power minus 1. Okay, divided by this is t to the power 1. Just when I have to solve this, so this is L1 t to the power minus 2. Very simple. Okay, so these are velocity, acceleration. Then you can also find out the density. Then you can also find out work. Suppose I have to find out the work done. Okay, let us find out work done or energy, because both the dimensions become same. Okay, work done or energy. So work done formula all of you know, or if you don't know, then we will discuss in the later chapters. So the formula becomes F into S, that is force into displacement. Remember, force into displacement. Again I will repeat. So the formula for work done is F dot S or Fs. Okay, so that is equal to force. Okay, so just in the previous, I know the formula of F. Okay, so force is nothing but mass into acceleration. So just I solve, that is M1 L1 t to the power minus 2. Just previously we have discussed M1 L1 t to the minus 2. And what is S? S is the displacement, and displacement is nothing but the length. Okay, so length means this is your L1. Length means this is your L1. So now simply this is M1 L2 t to the power minus 2. So in this way you have to find out the dimensional formula. Remember the dimensional formula of different physical quantities. Okay, and these powers, remember 1, 2, minus 2, or 1, minus 2, or 1, minus 1, these are your dimensions. Okay, and the whole formula is your dimensional formula. And the dimensional formula must be written within a square bracket. Remember that is clear. So these are how to find out the dimension or dimensional formula of different physical quantity. So you have to remember these two and you have to practice in the copy. Clear? Now next come to your dimensional equation. Suppose this equation. Okay, so why it is called dimensional equation? Because the dimensional equation is nothing but this is the, look at this expression, this is the dimensional formula, and so also we can call it a dimensional equation because these physical quantities compared with the dimension of the fundamental or basic physical quantities. Remember this is, okay, this is your LHS, this is your RHS, very simple. So LHS is your velocity which is compared with the dimensional formula of or with respect to the fundamental units. Remember that is fundamental physical quantity means length is your fundamental physical quantity, time is your fundamental physical quantity. So as these two are compared, okay, this is LHS, this is RHS, that's why this can be called dimensional formula, and also this can be called your dimensional equation. Very simple, because we know that in the mathematics the equation consists of two parts. One is LHS, one is RHS. When these two are compared, okay, then we can call it as a dimensional equation. Very simple. Okay, so now with this concept, let us move into the dimensional analysis. Okay, so dimension, whatever we have discussed in this session, that is how to find out the dimensional formula, what are dimensions, and what is a dimensional equation. Clear? So now these are the very important things to discuss into the dimensional analysis. Clear? Okay, because in the dimensional analysis, first of all we have to know what is principle of homogeneity of dimension. This is the first thing we must have to know, okay, before going into the dimensional analysis of different physical quantities. First of all we must have to know what is the principle of homogeneity of dimension, of any dimensional formula of any dimensions. Clear? So what are the principle of homogeneity says? Let us look at very carefully. What are the principle of homogeneity says? Now in a dimensional equation, whatever the dimensional equation I have to mention here, okay, so in a dimensional equation or in a dimensional formula, if the dimension of LHS and the dimension of RHS are same, then this formula is dimensionally correct. Clear? So this is your principle of homogeneity of dimension. Clear all of you? Again I will repeat. The principle of homogeneity of dimension says that in a dimensional formula, let us take an example. Suppose a dimensional formula is your velocity v. Okay, so v is equal to just, I find out that it is L1 t to the power minus 1. Okay, so this is your dimensional formula or dimensional equation. So in this equation, if the dimension of this LHS part and dimension of these LHS parts, both the dimensions are same, then it is called, or it is the principle of homogeneity of dimensions. Okay, now what is the application of principle of homogeneity of dimensions or dimensional analysis? What are the applications? The applications are very important. Okay, so the first application, look at the first application. The first application is that to analyze or to find out, okay, the first application to find out the relationship between the unit of physical quantities, okay, with different system of units. Okay, so this is the first application. In this class we will discuss, or we will concentrate on this part. In the next class we are discussing the next two, your application of dimensional analysis. So look at very carefully. So what is the first application? Now we have to find out the relationship between the unit of physical quantities, which are in a different system of units. That is very important. Okay, so what are the system of units we have already discussed just now? What are the system of units? The CGS, FTS, MKS, SI. These are the system of units. Okay, suppose a question is providing to you, and that we have to convert one system of unit to another system of unit. Let us take an example, very simple example. Look at very carefully. Suppose a question is from this is our aim, or this is the application. What is the application? Again I will repeat. We have to find out the relationship between the units of physical quantities with different system of units. That means the physical quantities unit are into different system of units. Suppose one is in MKS, another in CGS. Okay, either we have to convert the CGS to MKS, or we have to convert the MKS to CGS. How? Let us find out. Okay, so suppose a question is given to us that convert, okay, that is 1 unit of work done in MKS. We have to convert 1 unit of work done in MKS to, okay, how many units of work done in CGS. Clear? That means we have to convert 1 unit of work done in MKS to how many units? The question mark means how many units of work done in WD means work done in CGS system of units. So what is our aim? Very simple. Now our aim to find out or to convert the work done from MKS to CGS. Very simple. Okay. So let us, so first of all, to solve this type of questions, okay, we first, our aim to find out what is the dimensional formula of work done first. Okay, so look at, all of you look at very carefully. So we have understood the aim. The aim is we have to convert the unit of work done from MKS to CGS. Clear? So what is the unit of work done in MKS? The unit of work done in MKS is your joule. Okay, so we have to convert the joule into the CGS unit of work done, that is your org. Okay, so let us find out 1 joule is equal to how many org. Clear? So look at here very carefully. So first of all, what is the dimensional formula of work done? Let us find out. So work done W is equal to the dimensional formula. Just try to find out what is the formula. Now M1 L2 T to the power minus 2. If so, to find out this, you have to solve this. Let us first let us solve this. So work done is equal to that is Fs simply. So F is equal to that is your mass into acceleration into S. Okay. So mass is just I solve this. So let us, this is your the mass dimension or formula is your m1. Acceleration is your L1 T to the power minus 2, and this is your S means time, and this is nothing but your T1. So let us combine this. So what is this one? Now M1, this is L2, this is T to the power. So this is your L1. So M1 L2 T to the power minus 2. Clear? So again I will repeat. Mass is the dimension is m1, acceleration is L1 T to the power minus 2. Okay, and S is nothing but displacement. So this is L1. So m1 L2 T to the power minus 2. Okay, so now I find out what is the dimensional formula of this. So let us apply this to convert this. Okay, so now the dimensional formula of work done I have written here. So dimensional formula of work done is equal to m1 L2 T to the power minus 2. Okay, so I have to mention two parts. One is MKS, another part is CGS. Very good. Okay, so now in MKS, that is your 1 meter. That is here. This is 1 meter. This is 1 kilogram. kg, and this is your 1 second. So we have to convert this to this. We have to convert this MKS to CGS, not CGS to MKS. It's very important. Okay. So now the dimensional formula I have to mention here M1 L2 T to the power minus 2. Clear? So now we have to convert this to CGS. So 1 meter is equal to how many centimeters? Let us find out. So this is 10 to the power 2. Very simple. Okay. So 10 to the power 2. The M, and what is the power? Look at here. The power of M becomes 1. Clear? Then come to kg. So kg, when I am converting to gram, this is your 10 to the power 3. This is your so this is your okay. So let us find out. So this is mass. Okay, little bit confused. Okay, let us again I will do it. So this is your M stands. So this is your M stands for your mass. This is okay. So now first of all, this is mass. This is length. So mass your 1 kg. Okay, so this is your M. Okay, then this is your 1 meter. This is your L. Then this is your 1 centimeter, your second. Clear? This is your T. So now 1 kg. Very simple. So 1 kg is equal to 10 to the power 3 gram. 10 to the power 3 gram. Okay. So this is your M. So gram means. So again I repeat here. This is your gram, but the power I have to mention here. What is the power? The power is 1. This is gram. Okay. So now come to this. So this is your 10 to the power 2 L. What is the power? The 2. Okay, so this is your length or gram. This is your centimeter. Then come to second is second. So the power becomes nil. So 10 to the power 0 T to the power minus 2. This is your second. Okay, so now I have converted this one. Just so now that implies so this is simply M1 L2 t to the power minus 2 in m case is equal to, look at it, so 10 to the power 3 to the power 1, how much? 10 to the power 3 to the power 1, how much? 10 to the power 3, and this is m to the power 1. So I will mention here m to the power 1. Very simple. Clear all of you? Okay. Now this is 10 to the power 2. Look at here all of you. 10 to the power 2. This is 2. So 10 to the power 4. And this is L to the power 2. Okay. Now come to here. So 10 to the power 0 minus 2. So 10 to the power 0. Okay. But that is t to the power minus 2. Okay. So now that implies, so this is m1 L2 t to the power minus 2 is equal to 10 to the power 3, 10 to the power 4. This is nothing but your 10 to the power 7. And let us accumulate this one, m1 L2 t to the power minus 2. So this is in MKS, this is in CGS. Very simple, converted. Now what I can write here? Simply obtain 1 joule in MKS is equal to 10 to the power 7 or in CGS. Converted. Because we know that now 1 unit of, because what is our aim? What is our aim that we have to convert 1 unit of work done in MKS. So what is the 1 unit of work done in MKS? 1 joule. Okay, so that should be 10 to the power 7 unit of work done in CGS. What is the unit of work done in CGS? Work. So 1 joule is equal to 10 to the power 7 work. Clear all of you students? So in this way we can convert it from one system of unit to another system of unit a physical quantity. Clear all of you? And similarly, you can also convert the CGS to MKS. Very simple. This is I have converted the MKS to CGS. 1 joule is equal to 10 to the power 7 work. Okay. So now we can also convert the CGS to MKS. If you convert the CGS to MKS, then you have to look at it. You have to, here I have mentioned 1 kg is equal to 10 to the power 3 gram. So there you have to mention 1 gram is equal to 10 to the power minus 3 kg. Very simple. Very simple. So just the converse. Clear all of you? Okay, so this is how the first application. You can also convert different things from MKS to CGS or FPS to your SI. So these conversion you can done very easily using the principle of homogeneity. Look at here. Here also principle of homogeneity satisfied. Because principle of homogeneity, what it says? It says the dimensional, your formula or dimension of that physical quantity must be same on both sides. So look at it. The dimension formula is same on both sides. M1 L2. The minus 2, the minus 2. And the 7 is the quantity, which is very, so 1 joule is equal to 7 log. Very simple. Clear, dear students? Okay, so this is the first application of your dimension analysis. Thank you so much. We will, in the next video, we will move into the second and third application of dimension analysis. Have a good day.